Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 283. Page number 283. Today is our lesson number 128, problem number 99, the second last problem on the page. This problem is something that we already solved yesterday. Yesterday we solved this problem in a little bit different way. Today we're going to do the same problem with a second method. This method that we are about to employ is the exact same method that you will find in the back of the book. In the back of the book, where they give you the answers and the explanation, that's where you will find this method. What happened was, when I was doing this problem, the very first thing that clicked in my mind was the method that I did yesterday. That's what came through my mind. But then, out of curiosity, as always, I go in the back of the book to see what they have to say, because once in a while it's interesting as to what they have to say. A lot of times that they just go on, and it's a real migraine to actually read the whole thing that they give you, the so-called explanation. But once in a while it's actually quite helpful. So I looked in the back and I saw their explanation, and I realized that probably their method is better than what I did yesterday. It's more elegant, it is more simple. So let's do it together, shall we? Now, before we actually embark upon the method that they give you in the back of the book here, there are some basic things that you have to understand, because otherwise you're going to be lost right away. Here's what's going on. For example, if somebody gives us this situation here, let's say x minus 7 times x minus 3. I'm making it up, okay? And of course, if you expand it, we'll have our quadratic equation. If we are told that this is equal to 0, there are only two solutions to this problem. There are only two solutions to this equation. Since x minus 7 times x minus 3 is equal to 0, either x minus 7 is equal to 0, or x minus 3 is equal to 0. Or maybe they are both equal to 0, who knows? Which means that x equals to positive 7 or x equals to positive 3. These are called the roots. The roots of this equation are positive 7, positive 3. Now let's see what happens if we expand it. That gives us x squared. This is going to give us negative 3x. Negative 7 times x is going to give us negative 7x. Negative 7 times negative 3 is going to give us positive 21. And this whole thing equals to 0. Which means x squared minus 10x plus 21 equals 0. Now if you want to compare the two situations here, this x squared has a coefficient of 1, and so does this one. So a equals 1. Our b here, our b equals negative 10. This is our b. And our c is positive 21. C is positive 21. But as you can see, this equation, x squared minus 10x plus 21, can be written as x minus 7 times x minus 3. Because 7 and 3 are the roots. Are you with me? Positive 7 and positive 3 are the roots of this equation. X squared minus 10x plus 21. The roots of these equations are positive 7 and positive 3. Therefore, this equation can be written as x minus 7 times x minus 3. Which is exactly what we're going to do here. The roots of this equation, x squared plus bx plus c, we are told are r and s. Therefore, x squared plus bx plus c can be written as x minus r, the first root, times x minus s. Let's open this thing. So we get our x squared, we get our negative sx, we get negative rx, and finally we get r times s, which is positive rs. Positive rs. We're almost done, but my marker, as always, is dying. I don't know why they die so fast. Now what do you notice? Well, if you want to simplify this thing, you could simplify it, but we are not interested in the coefficient of x. This part here, if you were to take out the negative, x, you'll end up with r plus s. R plus s, and here we have x squared and then rs. But we are not interested in this part. What we are interested in is what's the value of c. What's the value of C? Or rather, what we are interested in, I'll take it back. What we are interested in is the product negative? Is the product of R and S negative? We are interested in this part. And this RS must be C. So R times S equals C. R times S equals C. And as long as we can find out something about the coefficient C, we are all set. The rest of the solutions that we did yesterday is the same as this one. So in the first statement they tell you that B is negative, which is a worthless information. In the second statement they tell us that C is negative. Well, if C is negative and R times S equals C, then R times S must be negative. Answer is B. Alright? Let's do the next problem. That's it, we are done. So like I said, this is the different method. I don't know why it didn't click, why it didn't occur to me, why I did not think of it. But this is perfectly elegant, perfectly simple, perfectly beautiful solution. Let's do the next one, number 100. Number 100. I think I'm going to have to get rid of this thing permanently so that I don't keep picking them up. Give me a second. There, they're gone. Number 100. In question number 100, they give us a pie chart. This is actually a very simple problem. They tell us the total expenses. Total expenses, they tell us, are $5.4 million. The question simply is, how much is R? And here's our pie chart. And they tell us that the R is represented by this sector here, which is X degree wide. Well, as long as we can find out how much this X degree is, we are home free. That's all it is, because it's all proportional. That's all it is. And in the very first statement, they actually tell us how much X is. X is 94 degrees. But that's very simple then. If we know how much X is, that's enough. Now don't worry about the fact that my pictures are all shot to hell, they're not drawn to scale. As you can clearly see, I just realized that it is 94 degrees, which is, last time I checked, was more than 90, and this is not even 90. 90 degree would be a quarter of a circle, wouldn't it? 90 degree would have been, they must have shown you a very wide one, yes. 90 degree is a quarter of a circle. So this looks like a 90 degree, it is actually 94 degrees. It's a little bit like this. That's your X degree. But of course they would not they do not show the straight, oh they actually do. Not quite, but you get the idea. It's 94 degrees. So that's it, we are done. Statement 1 is enough because we know the degree, we can figure out AD, BCE. Since the first statement by itself works, the answer cannot be B, C or D. It has to be either A or D. As far as the exam is concerned, we are done. We're going to move on to the second statement and we'll figure out if second statement does any good or not. What does they tell you in the second statement? In the second statement they tell us that S plus T equals 2R. S plus T equals 2R. How do they phrase it? The total expenses for division S and T are twice as much as the total expenses for division R. S plus T equals 2R. Is that going to help us answer our question, which is, how much is R? How much is R? Does that help us? The answer is no. Second statement is worthless. Only the first statement gives us the answer, and therefore the answer to the question is A. That's all. Now as far as the exam is concerned, we are done. The answer is A. But just for learning purposes, just on chance that if something like this were to appear in the exam on a multiple choice question, we will have no choice but to figure out exactly what R works out to be. And you have to know how to do that in a reasonable amount of time and without a calculator. Let's do it together, shall we? For learning purposes. So we know now that because this is a whole circle, we have degrees and our dollar amount. And the total degree is 360. Total circle is made up of 360 degrees. Total dollar amount is 5.4 million. This is X degrees. Question is, what is the dollar amount for that? Let's call it D for dollar amount. And X we know is 94 degrees. X we are told is 94. So we have to solve for the dollar amount D. Let's find out. So 360 D equals 94 times 5.4, which means D equals 94 times 5.4 over 360. Now I don't know about you, but I'm not too keen about this 0.4 business. I don't like dealing with decimals. I want to get rid of it. So let's multiply the top and the bottom. Let's multiply the top and bottom by 100, okay? Let's multiply by 100 so that we can get rid of this decimal thing. So what we end up here is D equals 94 times 54 over 3,600. But I'm not going to write that as 3,600 because that will be very cumbersome to deal with. Let's break it up into 36 times 100. Now let's see what we can do. I'm going to do it right there because we need a lot of room. We're going to do the calculation right there. D equals 94 times 54 times over 36 over 100. Let's see what we can do. Now how do we know if a number is divisible by 3? A number is divisible by 3 if the sum of the digits of the number is divisible by 3. For example here, 5 plus 4 is 9. Since 9 is divisible by 3, therefore 54 is divisible by 3. And of course 36 is divisible by 3. 94 does not divide even into 3 because 9 plus 4 is 13. 13 is not divisible by 3. So let's do 54 and 36. Divide by 3. How many 3's in a 5? 5 has 1 3. The remaining 2 goes and joins the 4 becomes 24. How many 3's in a 24? 24 has 8 3's. How many 3's in a 1? I'm sorry, how many 3's in a 3? 3 has 1 3. How many 3's in a 6? It has 2 3's. Of course that was silly because we know 36 divided by 3 is 12. We're just learning the method. Again, let's go one more round. I think we can go one more time by 3. Divide the top and bottom by 3 one more time. So this becomes 4 and this becomes 6. Let's divide top and bottom by 2 one more time. So this becomes 2 and this is going to become 3. What else can we do? Oh, I see a 2 and I see a 94. 94 can be divided by 2. How many 2 is in a 9? 9 has 4 2's. The remaining one goes and joins the 4, becomes 14. How many 2's in a 14? 14 has 7 2's. Voila! Now it's very simple. It's just 47 times 3 over 100. 47 times 3. Again, even 47 times 3, you don't have to spend a lot of time. I'm doing this thing on the blackboard just to show you here. In the real exam, I wouldn't actually do it like that. I'm just, because I can't just stand here and talk about it. So I have no choice but to actually write it down. 47 times 3 is what we have to figure out. What we have to understand here is that 7 times 3 is 21. 1, carry 2. 21. One more time. 7 times 3 is 21. 1, carry 2. 3 times 4 is 12, plus 2 is 14. Voila. It must be 141. 141, and it makes perfect sense. Why does it make perfect sense? Because we know that 50 times 3 is 150. Everybody knows that. 50 times 3 is 150. 47 is only 3 less than 50. So 3 3's are 9. So you take away 9's from 150, you get a 141. So it's 141 divided by 100, and that is equal to $1.41 million. How much does division R spend? The answer is $1.41 million. Voila. This is how you would do it if you had to do it in the exam on a multiple choice question without a calculator and without spending too much time. That's it. We are finally done with this page. I will see you tomorrow, okay? Bye now.